Good morning, everybody. Welcome back to lecture number 6. Last time we talked about voltage divider rule. صح? What did we say about voltage divider rule? The voltage gets splitted proportionally to the resistance value, that the voltage drop across each resistor. The bigger the resistor in series, keyword is in series, the larger the ratio of voltage drop it will take from the source. We did solve an example and we noticed that the voltage drop at R4 is the highest because 6 over 6 plus 2 plus 1 plus 1, and we said the kilo will cancel each other, right? Now, last lecture I was a little bit panicked. I thought we have to do voltage node in the syllabus, but apparently we just need to do KCL, current divider rule. Now, important. What is current divider rule? Current divider rule is, we said about voltage divider rule, we want to know the voltage without calculating the current easily. The key word here, it has to be in series. For the current divider rule, the CDR, the key word here is parallel. Current divider rule, طبعا هي current divider, R rule, I added R. The key word here is parallel. So we can calculate the current without the need to calculate the voltage. So you use VDR if you're lazy to calculate the current to get the voltage. You use the CDR if you're lazy to calculate the... في مشكلة؟ WhatsApp group? Okay. You use the CDR to calculate the current without the need to calculate the voltage. يعني لو سوينا جدول وقلنا VDR CDR. CDR is the keyword for VDR, it has to be in series. Keyword for CDR, it has to be in parallel. What you calculate in VDR is voltage, صح? What you calculate in CDR is current. So here, no need to get the current, no need to get the voltage. Try to understand this table and then you know CDR and VDR. So these are techniques. Once you master all the techniques, you will be able to solve any circuit. In this slide, this equation is only applicable for two resistances. That's only applicable for two resistances. Why? Because if you have 1 over R1 plus 1 over R2, if you multiply توحيد المقامات, if you multiply them, it's equivalent of R1, R2 over R1 plus R2. But if you have R3, then this is not applicable. You can't add R3 here. Get it? If you have more than 3 resistances, then you have to calculate the other formula. But this one is because we see a lot of time only 2 resistors in parallel. So we can say the equation to calculate I1 is IR2 over R1 plus R2 times I total, which basically the subscript of the other resistance. So for example, you calculate I1, it's R2 over the summation. If you want to calculate I2, it's R1 over R1 plus R2. What does this imply? It implies that the bigger the resistance, it will carry less current. Get it? Okay. Now, if you have more than 2, which is also applicable for 2 resistances, that's the original formula. It's R equivalent over Rx, where Ix equal I total. So in other words, you really need to calculate the parallel combination, which is always smaller than every individual one of them. So do we expect R equivalent to be larger than Rx or no? No. Always smaller. So the current gets distributed I1, I2, I3. So if you want to calculate I2, for example, you have to calculate R1 parallel with R2 parallel with R3 over R2. Now this formula becomes handy to save time in the exam. Get it? Let's do a quick example. So this is 15 ohm. What's R equivalent? R equivalent is 1 over 60 plus 1 over 30 plus 1 over 10 inverse, صح? So if you want to calculate, for example, I1 equals I source, which is 15 times R equivalent over R1, which would equal to 15 times something over 10. What is this something? 6.6. Then you do the math. What's the unit? Anybody did the math? 9.9. All agree? So that's a CDR for more than 2 resistors. If you have 2 resistances, then it will be easier. In other words, you have 9.9 here, and then here you will have the remaining will be distributed across the 30 and the 60. The remaining is what? 15 minus 9.9. Let's say it's 5.1. 5.1. 2/3 of it would go here. 1/3 of it will go there. So we can do also a KCL at this node, the bigger node. Now there is a misconception. These two are the same nodes, but we are zooming in to see what's going on inside this wire. What's going on here is actually IR2 plus IR3. So IN equal to I out. IN is IS equal I1 plus I2 plus I3. So this I1 plus I2 plus I3 goes through this cable. All of this we call it a node. Okay? Get it? Let's do another problem here. Use the voltage division principle to find Vx. Then find the source current, which is Is, using the current division principle. So again, this is an easy problem. What's 60 parallel with 30? 20. In series with 60? 80. So what's R equivalent? 80. So what's Is? 100 over 80. I want you to be able to solve it without the need to write all the equation. So when you get the quiz, try to solve it mentally. Get it? Okay? So what did we say Is?
100 over 8.
Is equal 100 over 8, which is, I don't know, 1.2 amps, okay? So what is Vs? To calculate using the voltage divider rule, we need to write it in a series form. How do we write it in series form? We have to keep the 60, and this parallel combination, we have to combine it to make everything in series. Keyword in VDR, series, get it? Keyword in VDR. Can we apply VDR in this shape? No, we have to find our equivalent, which is 20. Then you can use the easy thing, Vx, which is plus minus. The voltage drop here is Vx, the voltage drop here is Vx, plus minus. So Vx equal 20 over 20 plus 60, which is times the 100. I don't know. Is it 25?
25.
What?
25.
Why 25? Robert. ولا كده؟
25 عادي.
25. Why you say 24?
Me, I don't know.
Who said 24? 25. Get it? Simple examples, exercises. Use VDR. So the first question before we use VDR, is this in circuit in series? Yes. So what do we want to find? Let's find V1 by the calculator. So V1 equals, I want you to try to solve it mentally. 5 over the summation. 5 over 10 plus 15 plus 5 plus 30. Which is 1 over 12 times 120. So here it's going to be 10 volts. 10 volts. If we want to do, I want you guys to do V4 now. So V4,
60.
60.
60.
No, not, okay, 30 over 5 plus 10 plus 15 plus 30 times 120, which is going to be 60 volts. 60 volts. Again, if you do KVL, voltage rise 120 minus 10 is what? 110 minus 20, 90 minus 30, 60 minus 60, 0. Sanity check. Trust but verify. Now what's the trick in this problem? He's asking you to do VDR, keyword is series. So what's the trick? Combine what? R2 and R3. 5 and 7 parallel. What's the value? 1 over 5 plus 1 over 7, and then you click x1, right? The answer, you make it x1.
2.9.
2.9. 2.9 plus 7, or 2.9 over 2.9 plus 7. 7 because I said 3 plus 4 times 20. 5.88. Again, ya shabab, we are learning techniques to be fast. When section 1 and section 3, they all are well trained and you don't know how to use a calculator, they will beat us. صح ولا لا? Our goal is to get higher average than them. Okay? Get it? CDR. Which one of those circuits are more CDR friendly? Is it circuit B or circuit A? B. Why? Keyword. Parallel. So can we get our equivalent? It's easy. Our equivalent. Mentally. 10 parallel with 10 parallel with 10. What's our equivalent? 10 over 3. If you don't know, use the calculator. Remember I told you if you get two resistors, 10 and 10, the equivalent is 5? Remember that? Who doesn't remember that? When we had two resistors that are the same quantity, 10 and 10, to save 10 seconds in the test, you can say it's 5. Like what if there are 3? 10, 10, 10. It's 1 over 10 plus 1 over 10 plus 1 over 10. Inverse, which is 3 over 10. Inverse, which is 10 over 3. So key here, divide the same resistance 3 times. What if I bring you a, that's a good question for the exam. If I tell you R, and then there is, basically I'm telling you there is N resistors. Each one has a value of R. Forget about this. What's R equivalent? R equivalent equal R over N. So this is a nice question for the test. So 10 over 3. So we save 10 seconds in the test. Get it? Now CDR, what did we say the formula? Let's say IR1. What's R equivalent? 10 over 3. What's 10 over 3?
3.3.
Well, I'm going to say 10 over 3. Over R1, which is 10. So 10 will cancel with 10, you will have 1 over 3 amp. In other words, no, we're wrong.
Multiply by the.
Multiply by 3 times IS, so times 3. So you'll get 1 amp. Get it? Now how to fix this to be CDR friendly? Serious? R1 plus R2, 30.
Sure.
30 parallel with 15.
10.
1 over 15 plus 1 over 30, and then you do x inverse 10. So our equivalent is 10. So if I want to calculate I1, which is equal to 3 times our equivalent. What did we say our equivalent? 10
10.
over
10.
10 plus 20. Because we have to make it in a CDR friendly. You have to combine those two resistors and name it, for example, R4. But to save your time for CDR, because it's like 15. Get it? Over 10 plus 20. And what is I? R3? It's called I. What's I3? 10 over 15 times 3. What's the first answer? I1? 1 amp.
1 amp. Yep.
What's the second answer? 2 amps. KCL, in equal out, 3 equal, 1 plus 2. Always verify. Is the CDR and VDR techniques clear? To be honest, it's used but not many. Okay?
What is used the most?
What's going to be used the most is we're going to learn it. It's going to called nodal voltage analysis and mesh analysis. These are more standardized approaches. So let's mess around with this circuit. Find the voltage V1. So when I put V1 here, it means V across the 30 and V across the 10. So I am sorry, all the checkpoints, it was blurry. Now I fixed the issue. It's not blurry anymore. It's not going to be blurry anymore, okay? So now, when you zoom in by your iPad, it should be clear. And again, who doesn't like checking the slides every lecture? I make those changes real time. So always refer back to the latest version, okay? I know you write notes, but that's the only solution. In the YouTube, I'm solving it now. Checkpoints are questions from the book that I like them. Again, if you did not score 10 in the quiz, you have to see me. Okay? Basically, I'm not going to give you the quiz back. You have to come to my office. Well, I'm going to give you the quiz. I don't want to embarrass you in front of each other, but you have to come to my office, okay? So V1, we said it's the voltage drop across 30, across 10. So what does he want? He wants to get V2, and he wants to get what? V1. Which one is, you think, faster to calculate, V1 or V2?
V2.
Why V2? It's way far. It's V1. So a technique to solve V1 is to find R equivalent across this point and replace it with a single resistor, and then we use quickly VDR. So let me draw this, and hopefully you guys who watch YouTube put the quality 1080, then you should be able to see what we do here. The YouTube sometimes by default puts 720. I upload 4K quality, okay? So this is the 10 ohm. Now I'm gonna call this, I'm drawing this node and to the right. Drawing this node and to the right. So what we have here, 10 parallel with 30. Don't forget the units. We will lose points, 25 ohms, and then we have 5 ohms. What is R equivalent? And let's call this point A and B. It's going to be 30 parallel with 30. 15 parallel with 10. It's going to be, if we do it with R equivalent equals 5 plus 25 parallel with 30, all parallel with 10. I like this mathematical operation. So 30 parallel with 30, 15, parallel with 10, 6 ohm, are you sure?
Yes.
So 6 ohm. So we have here a voltage drop of 6, 3, 3, and I have 12. Mentally, 12 will get, half of it will appear here, the other half will appear here. So we expect this to be 6. But let's do VDR. So to do VDR, what we have here is 12, 3, and what did we say this? This is AB. R equivalent equal to 6, 3. So VDR, because it's series. Everything now is series. So V1 equals 6 over
12.
6 plus 3 plus 3 times 12, which is 6 volts. So I know this is 6 volts. I know this what? 6 volts. So I know here we have 6 volts appearing. Focus. Focus. How to get V2 without calculating the current is I need to take the circuit, and I know here it's V1. So 5 over 30 will appear here. 25 over 30 will appear here, multiplied by V1.
We will consider V1 as V total.
We consider V1 now as the new V total. So this is one technique. Key here is we don't want to find the current. We're lazy.
So the answer is 1 volt.
I don't know. Probably, yeah, probably. So now we have V1. What did I say? We say we have now, I'm drawing V1. So I'm only drawing here. I can include the 20, 30, it doesn't matter. What I'm going to call this as V1. And then here we have 25. And here we have 5. So I want to calculate V2. So are they in series with V1? Remember, in circuit analysis, we consider V1 as if it's a battery, because this battery could be another system. So we have here V1. We have here 25. We have here 5. 5 over 30 will appear here, times whatever V1. So V2 equals 5 over 5 plus 25. Many students forget to add the 5 here, times V1, which is going to be 5 over 30 divided by
Times 6.
I forgot, 6. It's going to be 1 volts. So the answers to this question, checkpoint, is 6 and 1 volts. Yeah. Because if you want to calculate this voltage, I'm giving you a technique to simplify this system to a simpler system. You know the voltage here is V1, صح? I don't care إذا هنا في شجرة، إذا هنا في أرامكو، إذا هنا في سابق, I don't care. As long as I know this is V1, I can apply VDR here. You can represent this, the whole system, by V1. The alternative approach, previously, what did we do? Oh, this is V1, do KCL, do KVL. Now we saved how many minutes in the test? Probably 5 minutes. Get it? 13 وال1 they are here. But I do not include them because I know the voltage drop across them. I do not include them. For me in VDR, if I know the voltage at whatever system, as long as the other elements in series, I do VDR. So here we did VDR. Any question about this checkpoint? Is this checkpoint clear? Now, the key point with VDR is you have to do always. Now, time is it? Now we have 1 minute. I'm not going to do it. So maybe next lecture we will start with this checkpoint and solve it. So any questions about the material? Any questions? Is it clear?
Yes.
So we are done with the whole syllabus. Now we're back on track. Maybe by the end of next week we will have the help session 1. Honestly, I'm going to make it the week after. So we will have 2. I'm going to teach. Now you have 2 TAs. The 2 TAs will have virtual, in-person office hours, so you can talk to them. As I told you, you can always send me a Teams. You can always contact me. If you do not understand anything, let me know, ya shabab, okay? So I'll stop the recording.